This is Chapter 7, Part 2. We left off on number 7, on 7-7. If you look at, you can't have the same enumerator as one group to another group. So in this case, there's John, and in this case, it's illegal to define John in the second group in this enumerator right here. Let's take a look at the next one. If you look at the syntax of the data type identifier with this thing, here's enum, sport, basketball, football, hockey, basketball, soccer, and volleyball. Such that you can declare this as sport. You see here how this is sport. And you can declare this under popular sport, for example. So one of the things that you're going to see is this: the place that you will declare this right here, it will be between your int main and you're using namespace with it. So this is out there in that global area that you can access later on with this thing. If you notice the sports, this defines you the popular sports, my sports, that you can actually use this data type with it. This will all make sense when I do the example with this. Values can be stored in enumeration data types. So you can do football, for example. Football is assigned to popular sports. Popular sports now stores into football with this. Okay, so football is now stored into the popular sports with this thing. All right, so bear with me again. The rule of the right hand of the equal sign is equal to the left hand side still exists with it. A couple of things. You can't do arithmetic operation or allow an enumeration type. First of all, you can't do increment or decrement in this thing. The solution is your static cast of this thing. If you remember your static cast syntax, this is this part between your parentheses, your expression. The sport part is your data type. So in this case, if I want to add one to the popular sport to the next one, I would actually add one, but I would cast it back to sports. If you remember what sports are, sports is what's if you want to move from basketball to football in this case. Okay, so that's static cast to sport, and all that's assigned to popular sports. Okay, so that's how it works with it as well. Just a few things. Enumeration type is an order set of values with this thing. So if I took football is less than or equal to soccer is true, let's take a look at football. If you look at football, here's football. Okay, so football is what? 0, 1, 2, 3, 4, 5. Football is 1, hockey is 2, baseball is 3, soccer is 4, volleyball is 5. So if you look at this expression right here, soccer, 0, 1, 2, 3, 4, 4 is greater than 1. Okay, so this is a true statement. It goes the same as hockey versus basketball. So you just count across the enumeration data type with this thing. An enumeration type is an integral data type and can be used in loops with this thing. So again, your for loop, because it's integral, you can set your basketball in this case to a particular integer value with this thing. Test the value with this thing, and you cast it to update it with it. Okay, same thing with this thing. So an enumeration type cannot be an input or output directly. You can't input or output this thing directly. So if you look at this particular expression right now, here's enum is your courses, okay, and you register as your course, okay. Now it's a data type that you have declared this thing. So you register this thing, and you can actually feed through whatever these values comes across with it. You can get an actual output with it as well. Enumeration type can pass a parameter to a function either by value or by reference. By reference. Remember reference variable is the address of your memory with this thing. So a function can return a value of the enumeration type with it as well. Can declare a variable of an enumeration type when you define an enumeration type. So you can declare this thing. Now you got to be careful with this thing is here's the data type is what? Grades. And you're declaring this A, B, C, D, F, okay, as the course grades with this thing. Let me stop right here.